All right, so 11.6 looks at scientific notation. So this is kind of an application of exponents, and this is something that's really useful in science classes where you may be working with very large or very small numbers, and it's kind of a simple way to express those numbers. So my goal when I'm writing the number in scientific notation is I want to have some number times 10 to some power. Now the number here is a number between 1 and 10. So that's really all you have to remember. So let's look at how one of these works. So 40. So my goal is, how do I write that as some number between 1 and 10 times 10 to some power? Well, what I do is I look at moving the decimal. So right now the decimal is here at the end of the number. So if I move the decimal one place left, I then have a number between 1 and 10. Okay, so how many places did I move the decimal left? One place. So in scientific notation, 40 is equal to 4 times 10 to the first. Here's another one. So how many places do I have to move the decimal left here to get a number between 1 and 10? 2. So this is 5 times 10 to the second. For these simple ones, you can kind of check it, right? Because 5 times 10 to the second, 5 times 100 is 500, right? 610,000. So that one's a little more interesting. So I can tell the number like 6.1, right? Because I need a number between 1 and 10. So then I just have to figure out the power of 10 here. So the decimal's here, so I move 1, 2, 3, 4, 5 places left. So that's 6.1 times 10 to the fifth. Now I could check that. I'd start with 6.1 and I can add as many zeros as I want here. So checking that, I'd move the decimal, let's see, 5 places. So 1, 2, 3, 4, 5. Okay, so that number would be 610000. And indeed, that's what I started with. So what about some of these going in the opposite direction? So looking at small decimal numbers here. So in this case, I actually have to move the decimal in the other direction. So I'm going to have 3 times 10 to the something. Now this time the power is going to be negative, because this time I actually have to move the decimal 2 places right. So 10 to the negative 2. Okay, how does that work if you wanted to check it? Well, 10 to the negative 2 is 1 over 10 squared. 1 over 100. So 3 100ths is 0.03, right? So that checks. Let's see. So here I know my number between 1 and 10 is 3.04. So how many places do I have to move my decimal to the right? Let's see. 1, 2, 3, 4, 5. Okay, so if I wanted to check that, I mean, I just put a bunch of zeros, as many as I want there. There's my number. I moved the decimal 5 places left. Okay, so then I'd have 0.000304, which is what I started with. What about 5? I mean, this is already a number between 1 and 10. So isn't that 5 times 10 to the 0? Because remember, 10 to the 0 is 1, right? Oh, here's another big one. 3.19 times 10 to the, let's see, decimals here, 1, 2, 3, 4, 5, 6, 7, 8. Should I check one more? 3.19. Add as many zeros on the end here as you want. Let's see. Move the decimal 8 times. It's here. So what is that number? 319. 1, 2, 3, 4, 5, 6. Did I count those right? Looks like it. Okay, this is going to be 7.5 times 10 to the negative 1, 2, 3, 4, 5, 6, 7. Okay, what about going from scientific notation into decimal notation? Oh, we've already kind of been doing that, haven't we? So let's see. I start with my number 4. Let's do it this way. 4.9. I can put zeros on either side of this. Okay, so 10 to the negative 1 means I move the decimal. Oh, I skipped number 1. We'll go back to that. One place left. So my new number is 0.49. Okay, skip this guy. Okay, so I have 8.2. Again, I can put zeros on either side of this, as many as I want, as long as the decimal's in the right place. Times 10 squared, so times 100, so 2 places right. So it looks like I get 820, 820. Just have to put the decimal in the right spot. Okay, times 10 to the negative 3rd. So I move 1, 2, 3 places left. And there it is. Okay, now I can multiply these together using exponent rules. So that's kind of cool. So look, don't I really just have 4 factors here? So I can multiply those 4 factors in any order I prefer. That makes this really convenient because I can use that rule. Remember that rule? If I have the same base and I'm multiplying there, I add the exponents. So that's going to be times 10 to the negative 9. Negative 4 plus negative 5 is negative 4 minus 5 is negative 9. Okay, the only thing is I have to be careful because this is not quite in scientific notation. Okay, because I have to move the decimal 1 more place to the left. So, well, a couple options for how I want to do this. I'm kind of thinking it might be kind of cool to use an exponent rule. Let's do it this way. let's say, okay, 10 to the negative 9th is 10 to the negative 1 times 10 to the negative 8, right? Because 24 times 10 to the negative 1 is what I need. That 10 to the negative 1 moves the decimal one place left. Okay, what about number 2? That's very similar. So I'll start with putting the constants together here, and then the exponentials. 4 times 2.5 is 10, isn't it? And then I add the exponents here. So 7 plus negative 4. Oh, this is an easy one, huh? This makes 10 to the 4th. So that's just 1 times 10 to the 4th. Oops. Sound travels at the rate of 1.127 times 10 cubed feet per second. How far does sound travel in 1 minute? So these are problems that you'll see come up a lot in science classes. These are unit conversion problems. So this is feet per second. So my goal is, how far does the sound travel in 1 minute? So what I have to do is get rid of seconds by using a conversion factor here. So I know there are 60 seconds in 1 minute. Okay, so you see when I multiply straight across here, I'm actually going to be able to cancel the seconds here. And my answer is going to be in feet per minute. That was the question, right? How far does the sound travel in 1 minute? Okay, so that's going to be 1.127 times 10 cubed times that 60. And then what's left is my feet per minute. Okay, so then I just have to simplify this expression, then I have the answer that I seek. Oh, so I don't know. I suppose you could use a calculator for this. 60 times 1.127. Let's see, so that's 67.62. So what I did is I used my calculator to multiply 60 times 1.127. Okay. So then I just have to deal with the decimal here. So let's see. I need to move the decimal one place left, right? So I have 6.762 times 10 to the 1, and then still times 10 cubed, right? So 6.762 times 10 to the 4th feet in 1 minute. All right, find the volume in meters cubed of a sphere with radius 6 nanometers. The volume of a sphere is given by the formula V equals 4/3 pi r cubed, and 1 nanometer is equal to 1 times 10 to the negative 9th meter. So let's see. So here we're interested in finding the volume in meters cubed. So right now we're working in nanometers. So I think the first thing I would do is I would use this fact. And I would say, can I first convert my radius to meters? Okay. So here I have to do a little unit conversion. So I have that 6 nanometers. And then let's see. So I need to get rid of the nanometers. So that's going to be in the bottom. So I know the 1 nanometer is equivalent to 1 times 10 to the negative 9 meters. Okay, so when I multiply straight across here, I'm able to cancel the nanometers, right? So let's see, then I'm going to have 6 times 1 times 10 to the negative 9 meters. This is my radius over 1, okay? So that's just 6 times 10 to the negative 9 meters. Okay, now I can answer the question about the volume using this formula. Okay, so that's 4/3 pi, and then my r. So 6 times 10 to the negative 9th cubed. Let me go ahead and put the meters in there. Okay, so let me see what kind of simplifying I can do. Let's see, what is 6 cubed? 36 times 6, 216? Okay, so what I'm doing here, I'm distributing to both the factors and actually also to the units here. So power to a power, I multiply the exponents. Now I'm going to be working in cubic meters. So let's see how I want to simplify this. So I have it's 4/3 times the 216, that's over 1, times the pi, and then times the 10 to the negative 27th. So let's see, 216 is divisible by 3, isn't it? That would be 72. So 4 times 72 times pi times 10 to the negative 27th cubic meters. $288 pi times 10 to the negative 27th. Okay, then of course I have to adjust my decimal here. So right now, I have the 288 times the pi times the 10 to the negative 27th, right? So what I'm interested in as far as the decimal goes is moving the decimal here. 2 places left. So 2.88 times 10 squared times 100 makes 288, right? So then what's the rest of this? Pi, and then my 10 to the negative 27th. So now let me rearrange. Put my exponentials together here. So it looks like 2.88 pi times 10 to the negative 25th cubic meters is the volume. So that one's a little more interesting.